Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Welcome to part 1 of our 4-part AWS reInvent 2025 series. Over the next 4 episodes, we're breaking down the biggest announcements from Las Vegas. Today, we're starting with what AWS called the defining theme of the conference, the rise of Agentic AI. But first, let's check what else is happening in platform engineering. The Model Context Protocol has won. If you've been wondering which standard would emerge for connecting AI models to external tools, the answer is now clear. MCP, which Anthropic open-sourced back in November, has become the de facto standard for AI tool integrations. The new stack called it, quote, an open standard that standardizes how AI applications integrate with external data sources and tools. What's interesting is how quickly the ecosystem consolidated around it. Major IDE vendors, cloud providers, and AI companies are all implementing MCP support. For platform teams, this means you can build tool integrations once and have them work across multiple AI systems.
And speaking of AI and code, Oxide Computer Company just published their internal policy on using LLMs for code generation. It's one of the most thoughtful takes I've seen from a production engineering team. Their core principle? Wherever LLM-generated code is used, it becomes the responsibility of the engineer. They documented this in their public RFD, or Request for Discussion system. Engineers must conduct personal review of all LLM-generated code before it even goes to peer review. The reasoning is fascinating. They note that LLMs are great at experimental or auxiliary code, but, quote, the closer code is to the system that we ship, the greater care needs to be shown. It's about ownership and responsibility, not just approval checkboxes.
Now let's dive into AWS reInvent 2025. Alex, the theme this year was unmistakable.
Agentic AI was everywhere. CEO Matt Garman set the tone in his keynote. AI assistants are starting to give way to AI agents that can perform tasks and automate on your behalf. This wasn't just marketing. AWS announced 3 frontier agents, a major platform for building custom agents, and a browser automation service. Let's unpack each one.
Let's start with some context. What's the actual difference between an AI assistant and an AI agent?
An assistant is reactive. It waits for you to ask a question, then provides an answer. It might help you write code or explain a concept, but you're driving the interaction. An agent is proactive and autonomous. It takes actions on its own. It can observe a system, identify a problem, analyze root cause, and either fix it or propose a fix. It can work for hours or days without constant human intervention. It navigates complex multi-step workflows across multiple systems.
And AWS announced 3 of these so-called frontier agents.
Frontier agents because they represent the cutting edge of what autonomous AI can do today. These aren't simple chatbots. They're designed to handle enterprise-scale complexity. The 3 are the AWS DevOps Agent, the AWS Security Agent, and Kiro, the Autonomous Developer Agent.
Let's start with the one that matters most to our audience, the AWS DevOps Agent. Walk us through exactly what it does.
Think of it as an autonomous on-call engineer. It's designed to accelerate incident response and improve system reliability, and it works 24/7. No sleep, no coffee breaks, no context switching. It's always monitoring.
How does it actually work under the hood?
It integrates with your existing observability stack, CloudWatch for metrics and logs, GitHub for code and deployment history, ServiceNow for incident management, and it can connect to other tools in your stack. When an incident occurs, the agent pulls data from all these sources simultaneously. It correlates signals that a human might take 30 minutes to gather. Error rates spiking in CloudWatch, a recent deployment in GitHub, similar incidents in ServiceNow history. It connects the dots.
So it's doing the initial triage that usually consumes the first chunk of an incident.
Exactly. But here's the critical part. It stops short of making fixes automatically. Once it identifies the root cause, it generates a detailed mitigation plan. This is the specific change to make. These are the expected outcomes. Here are the risks. An engineer reviews that plan and approves it before anything gets executed.
So humans are still the gatekeepers.
That's intentional and explicit. Amazon's documentation states, quote, "To keep frontier agents from breaking critical systems, humans remain the gatekeepers." This is a trust-building phase. The agent does the analysis, you make the decision. Over time, as these agents prove their reliability, we might see that approval threshold shift. But for now, human judgment stays in the loop.
And it's in public preview right now.
Yes, which is actually the perfect time to start experimenting. You can integrate it with your existing incident management workflow. Figure out how it works alongside PagerDuty or OpsGenie. Understand what the handoff looks like. Train your team on reviewing AI-generated mitigation plans. That's a different skill than writing runbooks yourself.
What about the AWS Security Agent?
The Security Agent is also in preview. It's designed to secure applications from design all the way through deployment. What makes it different from traditional security tools is that it's context-aware. It actually understands your application architecture.
Explain what that means in practice.
Traditional static analysis tools look for patterns. This code uses eval. That's potentially dangerous. This SQL query isn't parameterized. That's a risk. The Security Agent goes deeper. It understands what your application is trying to accomplish. It can do AI-powered design reviews, catching security issues in architecture decisions before code is written. It performs code analysis with understanding of data flow across your entire application. And it can run contextual penetration testing, knowing which endpoints matter most.
So it's more like having a security engineer on the team than running a scanner.
That's the goal. And for platform teams, this could mean shifting security left in a much more practical way. Instead of handing developers a list of CVEs to fix, the agent can participate earlier in the process.
Now let's talk about Kiro.
Kiro is the autonomous developer agent, and this one is already GA, not preview, generally available. It navigates across multiple code repositories to fix bugs and submit pull requests. AWS has hundreds of thousands of developers are already using it globally.
That's a significant number.
And here's what makes it interesting. Amazon has made Kiro the official development tool across the company. They're using it internally at scale. It learns from your team's specific processes and practices. It understands your coding standards, your test patterns, your deployment workflows. When it submits work, it comes as a proposed pull request. A human reviews the code before it gets merged.
So again, the human review step.
Always. Amazon describes it as, quote, another member of your team, but a team member whose work you always review before it ships, which, if you think about it, is how you'd treat any new developer.
Any incentives for teams to try it?
Amazon is offering free Kiro Pro Plus credits to qualified startups. You have to apply through the AWS Startup Program before the end of the month.
So we've got these 3 frontier agents. What about building your own custom agents? What's the infrastructure story?
Amazon Bedrock AgentCore. This is the platform for building production-ready AI agents, and they announced major enhancements at reInvent that address the biggest challenges enterprises face.
Walk us through the key capabilities.
There are 4 major announcements. First, policy controls. You can now set explicit boundaries for what agents can and cannot do. This agent can read from this database, but not write. This agent can access production logs, but not customer PII. Guardrails that are actually enforceable. Second, memory. Agents can now log and remember user patterns across sessions. They learn from interactions over time. This is crucial for agents that work with the same users or systems repeatedly. Third, evaluation systems. AWS added 13 pre-built evaluation frameworks for monitoring agent quality. Is the agent's output accurate? Is it following the defined policies? Is it degrading over time? Fourth, natural conversation abilities, improvements to how agents handle multi-turn conversations with context retention.
And then there's Nova Act, which caught my attention.
Nova Act is a new service specifically for building browser automation agents. Think about the workflows that still require humans to click through web interfaces. Form filling, search and extract, shopping and booking flows, QA testing of web applications.
Browser automation has traditionally been fragile.
Which is why the key stat is so impressive. 90% reliability on early customer workflows. That's on real enterprise workflows, not just demos. It's powered by a custom Nova 2 Lite model that's been optimized specifically for browser interactions.
Now here's a sobering stat. Gartner predicts 40% of agentic AI projects will fail before 2027.
And AWS addressed this head-on. The primary cause of failure is inadequate data foundations. They identified 4 specific barriers. First, data silos. Agents need to access information across systems, but most enterprises have data locked in disconnected silos. Second, trust in data. If the data an agent uses is stale, incomplete, or inaccurate, the agent's outputs will be too. Third, cross-organizational governance. Who's responsible when an agent accesses data from multiple teams? What are the audit requirements? Fourth, data consumption patterns. Agents consume data differently than humans. They need APIs, not dashboards.
So you can have the most sophisticated agents in the world.
But if your data's a mess, they won't work. Platform teams thinking about agentic AI should probably start with a data readiness assessment. Are the systems these agents need to access actually accessible via API? Is the data fresh and accurate? Do you have the governance frameworks in place?
Let's talk about what this all means for platform teams specifically. Werner Vogels gave his final reInvent keynote after 14 years, and he introduced a concept that every platform engineer should internalize.
Verification debt.
Explain it.
It's a new form of technical debt specific to the AI era. AI generates code faster than humans can comprehend it. That creates a dangerous gap between what gets written and what gets understood. Every time you accept AI-generated code without fully understanding it, you're taking on verification debt. That debt accumulates, and at some point, something breaks in production that nobody on the team actually understands.
So code reviews become even more important, not less.
Vogels was emphatic about this. He called code reviews, quote, the control point to restore balance. He said, we all hate code reviews. It's like being a 12-year-old standing in front of the class. But the review is where we bring human judgment back into the loop. It's interesting because this aligns with what Oxide said in their LLM policy. The organizations taking AI seriously are also the ones emphasizing engineer responsibility and ownership.
So what should platform teams actually prepare for?
4 practical things. First, integration readiness. How will the DevOps agent fit with your existing incident management tools? Map out your current alerting pipeline. Where would an AI agent slot in? What would change? Start thinking about this now while the agent is in preview. Second, trust protocols. Establish clear processes for approving AI-generated fixes. Who can approve? Senior engineers only? Or anyone on call? What's the review bar? How do you handle disagreement with an agent's recommendation? Third, skill evolution. Your job shifts from writing runbooks to evaluating AI mitigation plans. That's a different skill. It requires understanding both the systems and the AI's reasoning. Start building that capability now. Fourth, embrace the hybrid model. AI handles triage and analysis. Humans handle judgment calls and approvals. This isn't about replacement, it's about augmentation.
So this isn't about AI replacing on-call engineers.
It's about AI as the first responder. The agent does the initial analysis. It pulls the data. It proposes a plan. You make the decision with full context instead of spending 30 minutes gathering that context yourself. The role evolves, but it doesn't disappear.
Let's wrap up with key takeaways. First, frontier agents are here and available now. The DevOps Agent and Security Agent are in public preview. Kiro is GA with hundreds of thousands of users.
Second, Humans remain in the loop. All these agents stop at the approval stage. You review, you decide. This is intentional and probably won't change soon.
Third, integration is everything. Success depends on fitting these agents into your existing workflows, not replacing them wholesale. Start mapping that integration now.
Fourth, verification debt is real and growing. AI speed creates new risks. Code reviews and human oversight are more important than ever. Organizations like Oxide are already building this into policy.
Fifth, data readiness might be your biggest blocker. 40% of agentic AI projects are predicted to fail because of data issues. Assess your data foundations before investing heavily in agents.
And sixth, start experimenting now. Preview access means you have time to learn before these go GA. Build the muscle memory. Train your team.
Next episode, we're continuing our reInvent coverage with Part 2. Graviton 5 with 192 cores, Trainium 3 with 4.4x performance and 50% cost reduction, Lambda durable functions that can run workflows for an entire year, and Werner Vogels' Renaissance Developer Framework.
The autonomous DevOps future is being built right now. The question isn't whether to engage with it, it's how to shape it for your team.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.